Now it's time to move on to the last part of our hub. So we have to drill and counterbore for 3 socketed cap screws in 3 locations to suit the back of the chuck. Now, I've been caught out before with some Chinese stuff, and I'm just going to do a quick double check. To make sure our holes are evenly spaced. Okay, I had a boring head. I've still got it. Where they drilled the mounting holes in the factory, they bozoed the hole locations. So yeah, just quick check, and they are evenly spaced. So we're good to drill on a fixed PCD. So we'll get this set up in the hub will get set up in the rotary table and knock it off. Okay, quick easy way that I use, just put with the indicator onto the rotary table in neutral, and just sweep the spindle and move your X and Y axis accordingly till you get the same readings in 4 locations. Okay, so we'll get our part indicated in, clamped down, ready to drill. Just a simple clamping setup we got here, and we've got 3 spacer blocks underneath just so we don't drill into our rotary table when we drill through. So it's just plonked on. So just for a bit of initial setup, I'm squaring against the edge of the part and one of the rings on the rotary table. The part's got to go across that way just a tad. So we'll just do this in a couple of locations. Dogs are going off this morning. People have these bloody yap yap dogs and can't control them. Okay, that's close enough now to put an indicator on it. So we'll just give these a very light nip. Okay, let's get an indicator set up. Fair bit of a high point, so just looking for the high spot. Whoops. Bloody camera. Bloody dogs. Fucking heaps of shit, those things. Still, won't be an issue once we're out in the new shop. Okay, we're good to go there. So just very gingerly, a little at a time, nip these down. Recheck. Retap. That's looking good there, so we can just give them a final nip. They don't need much, remember we're only drilling holes. Okay, that's good to go. We're about half a thou there. Happy with that. So now what we've got to do is figure out our pitch circle diameter that we have to drill these holes to. Now, without getting too overcomplicated on a pitch circle diameter, for some clearance holes, we'll just do a simple method. So we've got 130 OD on our chuck, 3 cap screws screwed in. All I'm going to do is take a measurement from the inside of the cap screw and sight down the edge of the chuck. And I'm doing it over a white piece of paper so I get a definitive line I can see. So we've got 11.5 millimeters between the outside of the chuck and the inside of the bolt. So our bolt is 8 millimeters diameter. So if we take 4 millimeters off that, 1, 2, 3, 4 gives us 7.5 millimeters. Times that by 2 equals 15. Deduct 15 from our OD 130 gives us a PCD of 115 millimeters. And we will be drilling clearance holes anyway as it locates on the register. Okay, quick easy double check. Our hole appears to be in the centre of the back machine spot there. So we can just check which it is. So it's just a simple 130 OD, 100 ID. So that means we split the difference between 100 and 130, which is 115, which is what we came up with in the first method. Okay, it's just a simple matter now moving the table across 57.5, which is half our PCD. You can move the table either way, 57.5, or you can move it that way, 57.5, doesn't matter. I'm moving in because it gives me, I can see what's going on, it's right in front of me. Plus it's a point in between the clamps where my rotary table is on a 0 marking to make it easy to index. So 57.5. Just there. Okay, so we're on location. Plenty of room behind, we're not going to interfere with that clamp hanging out against the mill. So I'll get a drill chuck set up and we'll spot some holes. Right, let's get our holes done. I've just got a spot drill in there. Spot drills are good It's a good use of a spot drill because it's got the length to clear the hub. Regardless of what you use, spot drill, centre drill, pillar drill, whatever, it's going to do the same thing. Okay. We have a slot drill in to counterbore our holes, as my countersink set doesn't cover this size, but a slot drill will be fine. And we have our depth stop set. So on I'm left, I've got a way to go on a depth stop. I'll just put a little spacer block in. Saves winding the screw all the way up and down, and it works fine. So we'll get camera set up, back in your stand, and we'll get some counterboring done. Okay, our depth is good. I'll get a countersink set up, I think, and we'll just give these holes a light countersink on the outside there and at the base of the hole down there, just to clear. Some of these cap screws have a bit of a radius under the head. So I just want to ever so gingerly break this sharp edge on our drilled hole at the base of our counterbore there. So we'll just give it a quick touch with the drill bit, and that will create the chamfer on the edge of the hole. That's all it needs. So our drill bit just broke the edge of that corner down inside that counterbore, which is exactly what we want. Right, time for a trial fit. Time for a new brush too, I think. Might see if I can buy a bulk box of them or something. Okay, let's head over to the bench for a final bit of... Actually, no, we won't. I'll just run a countersink through these rear holes first. Okay, let me grab our chuck. Hopefully it'll fit. This Allen key. That'll be right. One of these Allen keys has got a fatter bloody head on it. And that one. So it looks like the Allen key, the 1 out of 3 that I picked up to get the head size, had the smallest head on it. So I'll pop these in the lathe, just take a little bit off it, and we'll be good to go. Okay, we've got our heads machined down now, so they all fit in. We know our holes are looking good. Let's give this a bit of a final feels good. Okay, feels good. Lovely. So I think what we can do now, we can head over to the press and we can get our taper roller cups pressed in. Okay, that one went in beautiful. Second one. This one went in a tad easier, but this side had the .02 press fit and this side had the .03 press fit. It wasn't worth making them the same, as they both fall within bearing fit tolerances. Now, if you ever have to get them out, all you have to do is you could spot heat them with the oxy or a couple of spots with a weld, and you might pick it up. I've left a little lip just in there, and that's a land you can put a pin punch if required to knock the cones out. Right, let's move on and find where our shaft is. Okay, so we've just got to finish this end of the shaft off. So it's just a matter of turning the shoulder, or turning the shaft back to a shoulder, drilling and tapping a hole in the end. This we will hold in the headstock of the lathe using the Morse taper. So we're going to use a sleeve. That's all it needs. I'm absolutely not a fan of this method without a spindle protector. It's something I'm going to make or do something about one day, because these areas here are your most critical registration areas on the whole machine. And yeah, if you do want to keep them protected. So that's a future project. So I think we've got to find what our OD is and the length to turn this back to. So we have to take our shaft down to 25mm, leaving a 10mm shoulder at the back there. Which is there. So currently we should be at 36, which we are. So we'll take 10mm straight off roughing, that'll bring it to 26, and then we'll start measuring. When I'm turning stuff like this, where the stringy stuff's getting wrapped around, I always keep my hammer within arm's reach. That's what I use to knock the feed out. If the chips get wrapped up and coming round and round and getting too close to where my hand would be to knock the longitudinal feed out, I can just knock it out with a tap with the back of the hammer. Just a little thing to be aware of. How are we going for size? This should be 26mm, and we are bang on 26. So what I'll do, we'll clean up these faces and then we'll take our last millimetre off. Bang on 10mm there. So we are 37mm for here, and we are 41. So this has a tolerance of plus nothing, minus 0.5. So we can be 37 or we can be 36.5. So 4mm to come off. Okay, we're there. We're there. I'm just going to angle this tool around. Because this tool is not really a facing tool. So the swarf will get jammed on the back edge of the tool and get trapped between the facing machining. Okay, switch verniers. Make sure they're clean. So we are 25.97 or 25.97. So we'll bring it down to 25 mil. Okay, we just want to cool the part down so we can get a accurate measurement. Half a millimetre to go. Very slight taper in that. 0.01 to go there. 0.035 to go there. I might take a spring cut on that. .01 up there. We're bang on size down here. I'll tell you what we'll do. Oh, cheap! That's right where we need to be. Okay. Okay, last machining operation on the shaft. We have to drill and tap the end to accommodate the 3/8 UNC 12-point head screw. There. We'll run a plate tap down that just to square up the bottom of the thread. I think we were there. Yep. Now, we'll give that, I should have done that before I tapped it. Just give that a bit of a countersink. Okay. Make sure we have it mushed over the end of the thread. That's all good. Okay, we can take this part out and we've got a little end cap retainer to make. It's a little round disc that goes on the end to retain the bearing, and then we're ready to set up some bearing preloads.